Hello everyone. So in the previous class we were discussing about span. Okay. So in vectors span means we are having set of vectors that can be represented by linear combination of these vectors itself. Okay. So here I have simple definition for you to tell that in linear algebra, the span of a set of vectors, that's what it told now. V1, V2, V3 up to Vn. The span of a set of vectors is a collection of all possible combination of those vectors using scalar multiplication and addition. Okay, so we are representing vectors, we are making set of vectors, and these vectors are created by scalar multiplication and addition of the existing vectors only. And I gave you an example in the previous class also. For example, like this, you are having a vector I plus j. This is a vector v1. V2 is 2i plus 2j. So ultimately v2 is 2 times of v1. So I can represent v2 in terms of v1. Obviously v1 v2 are coming in a span. Point is clear. Okay, so if you have few vectors in space and the span is all the places you can reach by stretching or shrinking or flipping or adding those vectors together. So I'm having various vectors in a space, and if I can reach to those vectors by performing these mathematical operations, stretching, flipping, reverting the direction and all these, okay, if I can reach to this particular thing, that will be represented as a span. And this is what the concept says. So if we have 2D space, their span could fill up the entire plane if the vectors aren't pointing in the same or opposite direction. If they are pointing in the same or opposite direction, then the span will cover a line. If they are pointing in a direction, okay, that means in a same direction, then we can have a span like this only. Okay, like this only. All right. So vector v1, vector v2 is double of it. That means it looks like this format in a 2D space. This is v1 and this is v2. Obviously, that's what the statement said. If they are pointing in the same or opposite direction, doesn't matter. If they are in opposite direction, still they are a span. So span will cover a line. So this will be a line. A span will cover it. We can have minus v2 also. Okay, that will be opposite to v1. Twice of it. That will cover a span. Here it is. If we are having two vectors v1 1 0, okay, and v2 0 1, something like this. So the span of these is an entire 2D because you can reach to any point in a plane by adding or scaling these two vectors. If this is the operation you can do by adding or scaling the two vectors, if we can reach to any of the point, then we are going to consider them in a span. Okay, so the span is the set of vectors that tell you all the possible combination of these vectors to reach any of the point in the plane. defined by these vectors, then we call them as a span. Okay, and so many examples here I showed you in the previous class. Okay, this is the simple definition of a span. Okay, and then here I took an example. Okay, that I need to talk about the span of v1, v2, so I can find the value of c1, c2 that can be used to represent them. Okay, it's like not only 2D, like I can have more values here in the span. Like this is example number 2 where I'm having these values. So I can have c1, c2, like this also, c1, c2, c2, like this also. Just multiply c1 with these. So only the concern is how you can represent a vector in the form of another vector. Okay, because in a space you are available with many vectors, because in a space you are having different points. Now why this concept is important, let me share my entire screen and give you some thoughts related to it. Okay, let's discuss about this span thing, why this is important. Okay, see, let us consider 2D space only. This is a 2D space. Okay, we are having many points in the 2D space. Okay, fine. So these points can be represented by vectors. Now, check out point A and point B. Point A and point B. This is C. This is D. This is E. So these are the vectors for these particular points. Now, if I look at these two, the point A and B are coming in a line. In a line. So if I can represent A with a vector v1, definitely I can represent point B with some multiplication, so some scalar multiplication of v1. This is what I can do. It may be twice, it may be thrice. Also, it's not only about the scalar multiplication. They told that we can have addition also. For example, if I can reach to this point, like, okay, in this way, so you can have this vector plus this vector equal to this vector. Okay, this is also possible. If I mark it like here, this is this is 1, this is 2, the complete thing this is 3. So I can write like this: 1 plus 2 equal to 3, according to the property of vector addition. I can write it like this. So here the goal is, okay, there are many points present in a space. There are many points present in space. We can have a 2D space, we can have a 3D space. Right now I am dealing with a small statement. Okay, I am considering the 2D. So there are many points present. And what your concern is related to the data science and machine learning, your concern is to understand the pattern in the data. Okay, your concern is to understand trends in the data. So ultimately you're looking forward to identify relationship. Okay, relationship in data, that's what you're looking forward for. Relationship. So with the help of span, I am trying to find whether I can reach a particular point with this vector or not, because vectors are gonna help us. I know about point A, I can reach to the point B also, because they are coming in a line. Also, if I know point D, I can reach to point B here also, because they are having a vector addition. Okay, so understand the application, why we are doing this thing, and how maths is helping us for this particular achievement. Okay, so I want to reach data points, and with this phenomena, how much data points I can reach with the help of vectors. That's what the span is. And the way it created a set, okay, like v1, v2, v3. So anyhow, with scalar multiplication or with addition, if you can reach the data points span, I hope this makes a sense. Okay, so there might be different terminologies where you may find complicated maths, but now I have simplified it for you. So I hope you will not get confused ahead related to the span. Okay, now the next concept is about your subspaces. Okay, subspace. This is the next concept in your vectors. Okay, subspace and the basis of for a subspace. Now, what is a subspace? Subspace is a smaller space within a large vector space. It is like a subset that follows some rules as the larger space. To be a subspace, what it needs is include zero vector also, do nothing. Be close under the addition. That means if you add the two vectors in a subspace, the result is also a subspace. Be close under multiplication also. Okay, be close under multiplication also. That means if you multiply a vector with a subspace by any other number, that is still present in a subspace. Okay, now again, why it is considering this particular thing? See, everything revolves around the data. Everything revolves around the distribution of it. Okay, and we are looking forward to simplify the understanding of data. Okay, the understanding of the data. Okay, so the point is, it's saying that subspace. Subspace. See, we are having vector space. Okay, we are having vector space. A vector space is a huge space. Is a huge space. Why? It can be like a 3D, it can be 2D, it can be 4D. And as many as dimensions you are having, as many as vectors you are going to make. Okay, like this is 2D space. This is 2D. You are having points present in the 2D space. Okay, now it has converted into 3D. So we are having such kind of distribution. This is 3D space. And obviously, you are making the vectors to represent these points. Okay, so by making the vectors, now it has been converted into vector space. This is vector space. You are having a vectors in 3D. So this is now a vector space. Okay, what is the space? Space is a place where I can put something. That is what a space is called. We say, na, do you have a space? Yes, I am having. Can I keep can I keep something in that particular space? Yes, you can keep something. So what I'm keeping in a space? Right now I am having 2D space. So I can keep a point here. Okay, in your 2D space, I am keeping a point. And if I represent it in a vector format, this is a vector space. In this vector space, actually I am creating a subspace. I need a small place in this complete domain. I need a small place for me in this complete domain. That is a subspace. And subspace, creating subspace, it is having some property. Okay, some property. That's what been read. I read those property. That means it comprises of zero vector also. A vector which don't have anything, do nothing. That is a zero vector. जिसके पास कुछ भी नहीं है, nothing. That is a zero vector. Also, if it is closed under addition, that means if the two vectors get added, the resultant vector should also come under the same subspace only. Okay, so A vector plus B vector will result into C vector. So C vector should also be present in that subspace only. Okay, so what does it mean? To be very simple again, I am having 2D. This is A vector. This is B vector. This is C vector. So A vector, B vector, C vector, all vectors are present here in 2D only. This is a subspace. If I'm adding two vectors, it should not come into the third dimension. No, this is not preferred. No. Whatever be the subspaces, if you're adding the two vectors, it should come in the same subspace only. All right, got it. Fine. So with respect to addition, it should follow. With respect to multiplication also, that's what it said. That if you are having a scalar multiplication also, then also the resultant vector should be present here only. Okay, so let me give you an example. This is your 2D. Let's consider that it is my subspace. I am having a vector v. If I multiply this vector v by 2, this is the resultant vector. So this vector is still present in the same, in this 2D only. So obviously it's a subspace. It is following the property of subspace. So either 0, either addition, either multiplication, everything should be present here only, in this domain only. Then only it is called as a subspace. So why we are studying all these things, span, subspace? Because only the thing is data. Because of data. Because of data point, you are studying this thing. I need to understand the data. For that, I am representing the data from the origin in a space with respect to the vectors. Vectors have a property. So if I need to understand the data, I should be using vectors. I should be using the properties of vectors. Okay, so this will help me in understanding the data, because data is a free zone. But representing it in some spaces and applying vector concept to it, this will help me. Okay, okay, fine. That what is the distance between this point and this point? What is the distance? So you can say the distance is, okay, 2 plus 3, distance is 5 if I take Manhattan. But if I take the shortest distance, it is under root of 2 square plus 3 square. Who gave this concept? Vectors. Okay, you have applied Pythagoras theorem. All right. So the point, their presence, simplifying, understanding it is been done with respect to the vectors. That's why span subspaces. Okay, what more concept says related to the subspace? So here they are saying if you are having 3D, okay, so like a plane that goes through the origin is a subspace. Okay, so in a 3D, if I am having a plane that is present in a that is a subspace. And what is the basis? That means for a basis for a subspace is a small set of vectors that can create every vector in the subspace by combining them in a different ways. So whatever be the points, whatever be the vectors which are present in the subspace, okay, just like a span, v1, v2, v3, just like a span, vn. So by adding or by multiplying, if I'm getting any vector which is present in that subspace, that is called as a basis. Okay, so these vectors in the basis are the building block of a subspace. Okay, so ultimately what they said, if you are having a 3D and if you are considering 2D in it, or either you are saying that you are having two parallel vectors present in it, okay, so that will form a basis. With just two vectors, you can create another vector by stretching, shrinking, and adding them. This is a span. So if you can apply span concept in subspace, done. That's it. Okay, so the key points here is the number of vectors in the basis tells you the dimension of a subspace. How many vectors are there? That will be the dimension of subspace. If you are having two vectors, then it will be 2D subspace. Three vectors, 3D subspace. There can be different sets of basis vectors. You can make a different sets. But the number of vectors in the basis for the same subspace is always the same. You can make a different vectors, but the number of vectors in the basis is still the same. Okay, fine. So I am having more concept related to the subspace, but now it is much more written in a mathematical format. Here it is. Zero vector. That means I am having an entire domain. And in this entire, I am picking some space. Okay, so I hope again if I can correlate this thing with the set. You know about the set. And you know about the subset also. So if this is a set 1, 2, 3, 4, 5, so the subset is 2 and 3. 2 and 3 is a subset of this set. Same thing. We are having a space. Let us suppose we are having a 3D space. If I can make 2D space out of it, that means 3D. If I can draw a plane, if I can draw a plane, a 2D plane in 3D, then it is a subspace. Subspace. Okay, that's what it is saying. Okay, it includes zero vector also. It can have addition also. It can have a multiplication also. So any vector by adding, make a new vector that should also be present in the same subspace. By performing scalar multiplication also, it should present in the same subspace. That is a property, including zero. Okay, including zero. Fine. Okay, so that's what they said. This is the scalar multiplication. Okay, close under multiplication. All right. So if you are multiplying anything, it should come here only. Okay, in this region only. If I'm doing the multiplication. All right. So this is close under the multiplication. Under addition, same thing. This plus this is the answer. Okay, it should again come under the same subspace only, not going beyond. So these properties needs to be followed. So it's again it's kind of a span only. We are creating a space for span. That's it. That is a subspace. Okay, and here is the maths. What they are doing? They are saying that okay, we are having a span of vectors. Okay, take it, and this is how we can represent C1, C2, C3. C1 they can be zero, then the answer will be zero vector, and if they are not zero, if they are having some scalar value, so answer is a into x vector. That's it. Either we can perform the addition of the vectors also. You can have an addition of the vectors. Okay, to make a new vector x vector plus y vector. That's it. Clear. So don't get like, nah, sir, these are so many terms written. Nah, not at all. Not at all so many terms written. Very simple. Just they have mentioned a span. And the first case is of zero vector, where the values of all the C's are zero. Second, not zero. Okay, second, not zero. They are just considering a multiplication with A. That's it. So AX vector. That means a scalar multiplier. They are taking with a vector. And then in the next case, they are just taking the addition of the vectors. Okay, so this is what they are doing with the span. Okay, so the basis of a subspace, I already told. If a subspace has basis, any member of that subspace can be uniquely determined by unique combination of those vectors. Okay, so if I'm having v1, v2, v3, If I combine v1 v2, if I'm getting v3, this is a unique combination, and all v1 v2 v3 are present in that subspace. This is your basis. That's what we call as a basis. यानी कि what it means, any member of the subspace, any member can be uniquely determined. I can determine v1 by some combination, I can determine v2 by some combination, I can determine v3 by some combination, some unique combination. I can determine them. Okay, by either combining the vectors or by using some scalar multiplication, but I can get. So this basis is again a revert of what we know in span. Span, this thing only happens. I can make a vector which is present in that particular set. Here also it is saying the same thing. That you can you make a vector which is present in the subspace? Yes, I can make by any combination of the other existing vectors. This is what the basis of a subspace. So ultimately, what they are telling is, you have to just understand it in terms of data. It's not that what you are studying is related to the vector. Vector is an application here. The what terms you have studied vectors, these are application. The whole concept relies on data understanding. Because because what will happen when you are going to apply any algorithm, when you are going to apply any technique over the data, you mean to learn the patterns in the data, and there will be equation, there will be an equation, because machine learning models are mathematical statistical models. The only goal is to, what does this math and statistics do? To understand data distribution. So why we are focusing upon the vectors? Because they mean to identify the pattern. Anyhow, if I can know that if a point is present here, if another point is present here, can I reach to this particular point from here to here? That is a question. Can I reach? How I will identify the pattern in the data? The thing is, can I reach to the point? And can this be performed by addition? Can this be performed by multiplication of the vectors? Is it possible? If it is yes, okay, we can use the concept of span, we can use concept of subspaces. Okay, if someone says that okay, you have to look out for this domain only, subspace. So can I do by addition? Can I do by multiplication? This is what the subspace means. And you will be having a span of vectors. Just to the only goal, the only idea is to connect dot to dot. Then I can identify the trends or pattern in the data. This is the way. It's an approach. Okay, fine. So you have to relate. You have to relate that why we are studying linear algebra. If you are unable to relate, then okay, it's not like that, sir, you are teaching vector. So, sir, that we already know. Now we have already studied these vectors in our maths in our school. But why we are teaching this thing? What is the reason? The reason is you should be applying this vector concept over data distribution. And the goal is, because your model says I identify the pattern. So if I can club, if I can connect dot to dot, either by adding, either by scalar multiplication, this is how the model learns the patterns in the data. Okay, I hope this makes a sense. Okay, triangle inequality. Okay, so in vectors, I do have a inequality like this also. X vector plus y vector is less than x vector plus y vector. This is a property. Okay, this is triangle inequality vector property. Okay, and if x vector plus y vector is equal to this and this plus this, that means that x vector is equal to cy vector. where c is greater than 0. Another, again, property. So these are the property of vectors, because you are telling now addition of the vectors. So this is how you can apply the property and addition can be performed. Okay, fine. Now angle between the vectors, you know about this thing. Okay, angles also we have seen. Okay, these are the vectors. This is the angle theta between the vectors. Okay, this is, let us suppose, a, this is b. Here is the theta angle between the two vectors. Let us suppose the complete or the entire angle is alpha. Okay, entire angle is alpha. Okay, and theta angle is the angle between the vectors. So as per the concept of physics, what we have studied is a vector dot b vector, that is the dot product between the vectors, is given as magnitude of a, magnitude of b, cos theta, where theta is the angle between the vectors. So here I can put theta. Okay, and they are also being representing like, okay, this is x vector, this is y vector, this is alpha angle, this is x vector minus y vector, that is the resultant. Okay, so what they are writing here is x vector minus y, this vector, and something like this. They are putting. Okay, fine. So again, it's not a complex maths. It's a very easy maths. How we can achieve this x y cos alpha? How we can achieve this thing? It's not a big deal. Okay, and if you want me to derive this thing also, I can do for you. It's very easy. Let me draw. Let me draw this thing. Okay, let me draw this thing. Here is a vector A. Here is a vector B. The angle B makes with the x-axis is theta 1. The angle A makes with the axis is theta 2. So the angle between A and B will be theta 2 minus theta 1. Quite clear. Okay, fine. Theta 2 minus theta 1. So if I do apply a property of trigonometry, cos, if I take the cos of theta 2 minus theta 1, what it is? Cos A minus B. This is cos A cos B plus sin A sin B. Cos of A minus B is given as cos A cos B plus sin A sin B. Okay, fine. So here you can do, let me drop the perpendiculars. Okay, here also. Fine. If if this distance, you can take like okay, this distance is small a. Okay, and this entire distance is a small b. Okay, and again this distance, okay, this distance you can take entire as c, and this distance you can take entire as d, this much d. So what is cos theta 2? What is cos theta? Base upon hypotenuse. Cos theta 2. This is theta 2. Okay, this is theta 2. So what it is? Base upon hypotenuse. What is base? Base is a. Hypotenuse. What is hypotenuse? Base is a. Hypotenuse in this vector. That is perpendicular का square plus इसका square. Base का square. That is hypotenuse. It means a square plus c square. Okay, so let me write under root of a square plus c square. Dot. What is cos theta 1? What is theta 1? Cos theta 1 is, okay, cos theta 1, this is your theta 1 angle made by b vector. This entire is b. So again, b upon under root of ye. What is this? What is this? ये हो जाएगा, this distance is d, this distance is b, so it will be under root of under root of b square plus d square. Plus, what is sine theta? Sine theta is perpendicular upon hypotenuse, so now this will be like c upon under root of a square plus c square, and this will be d upon under root of a square plus c square. Here you will get all the denominator same, so ultimately you will be having AB plus CD divided by under root of A square B square under root of B square D square. That's what you are getting. This is cos of theta 2 minus theta 1. That will be your cos theta. That will be your cos theta. That is AB plus CD divided by under root of A square plus B square and under root of your c square plus d square. This will be cos theta. Okay, and and if you can check properly, AB plus CD, AB plus CD, this is the dot product of these two vectors. Remember, AB plus CD, this is the dot product of vector A and vector B. Okay, this is A vector dot B vector. ये dot product है दोनों का. If you can check properly, AB plus CD is a dot product of A and B vectors. And under root of this are the magnitude of these vectors. Magnitude of A and magnitude of B. These two are the magnitude of the vectors. So AB plus CD is the dot product of vectors. And how I get to know about this thing? If you want to write A vector, what you will write? How you are going to represent A vector? What is A vector? A vector is, okay, this is A and this is C. So A vector is A I cap plus C j cap. What is B vector? This is B I cap plus D j cap. Now it is actually the dot of these two. I का जो डॉट हुआ तो आया ए बी, सी का डॉट हुआ so I got सी डी. ओके, सो दिस इज द डॉट ऑफ दीज टू, मतलब डॉट ही है ये. एंड नीचे मैग्नीट्यूड है. ओके, and this is equal to cos theta, the angle between these two, and that's what I need to find. And this derivation, what I taught you right now, is very much important because I'm going to use this derivation again in one of the algorithm in machine learning, that is SVM, support vector machine. And this is simple maths and physics or whatever you want to understand. You can just a vector representation, angle, difference between the angle. I took cos theta, then I applied the trigonometric property cos A minus B equal to cos A cos B plus sin A sin B. This is trigonometry. We have learned in 11th class in Indian Educational Institute. Like if I do talk about Indian, okay, that's what we have studied. Oh, simple hai. This is cos theta. Okay, and if I do multiply here, तो ये हो जाएगा ए बी ए वेक्टर डॉट बी वेक्टर इज इक्वल टू ए बी कॉस थीटा. ये हो जाएगा ए बी कॉस थीटा. ओके, ऐसे हो जाएगा. ओके, एंड इफ यू डू अप्लाई प्रॉपर्टी ए वेक्टर प्लस बी वेक्टर का होल स्क्वायर सो ए स्क्वायर प्लस बी स्क्वायर प्लस टू ए बी यानी 2ab means, okay, don't take the magnitude, boss, don't take the magnitude. This is dot product. 2ab, it's a dot product. Okay, that means a vector dot b vector, and you very well know what is a vector dot b vector. This is ab cos theta. So this is a square, this is b square, and this is 2ab cos theta. Okay, and I guess that's what they are claiming here. Okay, I haven't seen what this document is saying. Okay, but yeah, here it is. It derived this thing, and I already derived this thing by taking cos and the angle, and the approach I took that was different from here. Here it is writing the straightforward formula, but I am not writing the straightforward formula. I use trigonometry. Okay, I use the concept of trigonometry. Okay, and I made a proper diagram. Okay, that this is a vector, this is b vector, these are the angles with the x-axis, and this is what you have to identify. Theta 2 minus theta 1. This is equal to theta, the angle between the two vectors. Okay, fine. And then after applying, I just put the values of these trigonometric equations, these terms. And I understood that A, B, C, D, what does it mean? A and B, multiplication. And this is the magnitude of A and B. Point is clear. I substituted. That's it. I got the value of cos theta. I cross multiply. So A vector dot B vector equal to AB cos theta. And if I take the square of A vector plus B vector, this is what I'm getting. And here what the equation says, or the vector properties. Okay, so this is how we can identify the angle between the two vectors. Okay, what next it is saying? So we are having perpendicular vectors also, orthogonal vectors also. Two vectors are perpendicular, the angle between them is 90 degree. That's what we know. Perpendicular means 90 only. And the dot product of two perpendicular vectors is 0. That also we know, because cos theta cos 90 is 0. So it's obviously 0 ही होगा वो तो उसमें कुछ है ही नहीं. All perpendicular vectors are orthogonal. Remember this line. Don't forget. Orthogonal means perpendicular. The vectors are perpendicular means orthogonal. The zero vector is orthogonal to everything else, even to itself. So dot product of 0 with any other vector is 0 only. So zero vector is perpendicular to each and every vector. That's it. So these are certain properties. So orthogonality, please don't forget. Perpendicular. All vectors are orthogonal. That means they are perpendicular. Or perpendicular vectors are orthogonal. That means. Okay, if they are perpendicular, orthogonal. Okay, fine. So this is about the vectors now. Okay, and then we came towards the matrices, and we need to solve the matrix. So to solve the matrix, we are having Euclidean form. I already shown you Euclidean form. Euclidean form, reduce Euclidean form. I shown you, and they are used to solve the system of linear equations. And for that, okay, you are representing data in form of matrix, and you do apply some operations. Okay, what operations? Okay, let me show you again. Euclidean, non-Euclidean. Here only in this document only, Euclidean and non-Euclidean form. हाँ ये देखो ये रहा. This is Euclidean form, and this is reduced Euclidean form. So what we are doing in the Euclidean form? We are trying to make zeros in the denominator. Here also we are trying to make a zero. So you know what will happen? If I am having three unknown x, y, and z, and this is kind of matrix I get. So f is equal to z, and then this plus this equal to y. So z I already know. So I can find the value of y. And if I know the y, I can find the value of x also. I hope you understood what I'm trying to say right now. It's not in a proper way, but this is the third term. Rest are 0. So directly I can get the value of third term. And if I get the value of third term, I can find the second term. If I get the value of second term, I can get the first term also. Straightforward. So this is Euclidean form. And this is reduced Euclidean. That means further reducing Euclidean to this extent, where I'm getting the diagonals one. So that will be reduced Euclidean form. So being as a student, I also do this thing when I was in college, when I was doing my engineering, and in my first semester, I was having a subject called as engineering mathematics. I do this thing, Euclidean form, matrices. Okay. So that's what the concept is here. Okay, it's going to give some tips, some rules, some properties that you are obviously going to represent data in a form of a matrix, and you are trying to find the value of unknowns. So you kindly reduce the matrix into Euclidean form, and if it is possible, kindly do further reduce the matrix into reduce Euclidean form. Okay, that's what you can do. So again, ये सब डेटा के लिए हो रहा है, एवरीथिंग ना व्हाट यू आर डूइंग दैट इज बिकॉज ऑफ डेटा ओनली. हाउ? सी, ये डेटा है, दिस इज योर data set. Okay, let me call it as a data set. Okay, you are having Excel sheet which are having the features x1, x2, x3, x4, x5. These are the features. Now, okay, this is structured data because you are representing it in a form of a tabular format. This is structured data, row column format. All right. So if I want to represent it in the form of a matrix, what I'm going to do is, okay, x1, x2, x3, x4, x5. These are the columns, and let us make a matrix. So whatever be the entries which are present here, na, just put it here. This is row number one. This is row number two, and so on. Okay, and so on. Okay, fine. And you are available with the unknowns. The equation will be like this. The equation will look like this: 2x plus 3y plus 7z equal to 10. X plus y plus 3z equal to 12. 3x plus 5y plus 2z equal to 14. So what you are going to do? What you are going to do? You will write like this: 2, 3. Just see here. 2, 3, 12. Okay, not 12, it is 7. So 2, 3, 7. Then 1, 1. 1, 1, 3, 3, 5, 3, 5, 2. Then x, y, z equal to equal to 10, 12, 14. 10, 12, 14. That's it. Okay, that's it. And you have to solve this to find the values of x, y, and z. You have to solve, and you have done. It's not new for you. Same thing. We are having a data. Same thing with this x1, x2 as the features. Here we are having x, y, z. Instead, I can write x1, x2, x3. That's it. So we are still dealing with the data only. We are checking out the representation of the data, how we can put it in the matrix format, and how we can solve the value of features. How I can get the value of unknowns. What is a better suitable? That if I'm having all these values present in the data set, what should be the proper value of the features x, y, and z, so that I can get the result. So what they will do is, okay, what they will do here, convert this thing into Euclidean format. Then later on, further convert this into row Euclidean format. That's what they will do. Okay, if they have given some example, let me check out. Okay, there are certain properties. First, go through the properties. The row with all the zeros are placed at the bottom. If you are having rows with all the zeros, put them at the bottom. This is the property of reduced Euclidean. In rows with at least one non-zero element, the first non-zero element from the left, also called as pivot element, is 1. The rows with at least one non-zero element, that means it is not zero. In a row, if there is one non-zero element, the first non-zero number from the left, the first non-zero number from the left, it's also called as pivot element. Okay, so if you are having something like this, okay, the scene is something like this: A, B, C, 0, D, E, 0, 0, F. Okay, so what actually this F is? What is this F? This is a non zero element in a row. This is a non zero element in a row. We are having single non zero element in the. If you are having all the. So if this is not present, matlab, if F is also 0, then property says that all the zeros should come at the bottom. A, B, C, D, 0, E, F, G, 0, 0, H, I, 0, 0, H, I, J, 0, 0, 0. All the zeros should come at the bottom. This is property number 1. If there is some non-zero element present in a row, that's what I'm seeing, J. It's a non-zero element which is present here. They are saying there should be at least one non-zero element, the first non-zero number from the left. The first non-zero number from the left is called as pivot element. Okay, so let me count from the left. Okay, from the left, this is the first non-zero element, or let me call it as a pivot element. Okay, see here, this is the first non-zero element from the left, pivot element. This is the first non-zero element from the left in a row, pivot element. So these are the pivot elements according to the property of Euclidean format. Okay, हाँ, वो reduce Euclidean है तो वो 1 होंगे. If I am not talking about reduce, if I am talking about Euclidean, तो Euclidean में these are the pivot elements. But if it is reduced, that means it is having 1 0 0 0 1 0 0 0 1. So these are the pivot elements which it is calling it as 1. Okay, here is a property. Then in columns which contain the pivot element, the only non-zero entry in the column is pivot element. Hmm. The only non-zero entry in the column is pivot element. Quite clear. In this column, pivot element is the only entry. In this column, pivot element is the only entry. In this column, pivot element is the only entry. Clear. वो तो नहीं भी बोलता तो भी पता था हमें. If doesn't says, then still the concept says that thing only. Okay, so you can see pivot element. This is also pivot element. This is also pivot. I already told you. Okay, first non-zero entry in a row is a pivot element. That's it. Finish. Okay, convert a matrix. Now, how to convert a matrix into reduced Euclidean format? You have to apply row operations. Row operations. And I hope we have gone through this thing in our these notes above. Okay, I hope they are present. Row operations. I guess we are not having, okay, those points. Okay, fine. Anyways, we'll get from here only. Okay, we'll get those things from here only. Okay, so convert a matrix into reduced Euclidean format, you have to apply row operations. In my own studies during that time, I apply again row operations, column operations. Only the thing was in my mind was ki as many as zeros I can make, na, let me do it. At that time, this was the thing in my mind. But when I grown up, I said that okay, I think I might be doing the mistake. I need to apply only the row operations. Ignore the column, not the column, just row operations. So if this is the question given to you, 8 minus 130, 4 1 minus 5 1 0 6 2 3. This is the question given to you. Okay, and you want to convert it into reduced row echelon format. Okay, reduced row echelon format. What should be the procedure? The procedure is, okay, that's what it is doing. First, it switch the row. This is a property. You can switch the rows. Row 1 can be made row 3, row 3 can be made row 1. Interchanging can be possible. Here they did. Second, they multiply row with a non-zero constant. That this is also possible. You can multiply scalar with any of the row. So they multiplied with 3 with the row 2. Okay, so this is the multiplication. Multiply 3 with row 2. Here is the answer. And then what they did? Add one row to another. That's what they did. Perform the addition. That means add row 1 and row 2. So this is what they get. So it's just showing you the operations, how we can perform. So these are row operations which you can do. And by these row operations, you can convert a matrix into echelon format. And then later on, you can further convert the matrix into reduced echelon format. It is possible. So if I'm having this matrix 8 minus 1 3, okay, let me take some small any small matrix. If I do take like 2 1 2 1 0 and 1 0 2 1 1, and like this is 0. I know that I know that the okay, don't take the 0. I guess this will create an trouble. Let us take 10 10 10. I know that the reduced echelon form says a b c 0 d e 0 0 f. This is echelon format. So anyhow, I need to make these two positions 0 to convert this into this format. So I need to apply transformations. And the possible transformations could be like addition, multiplication. That's what you can do between the rows. So I can make this thing 0 by subtracting row 3 from row 2. So row 2 minus row 3 can make this thing 0. So row 3 equal to row 2 minus row 3. So this will become 0. Why? Because 1 minus 1 will be 0. So your answer will be 2 1 10, 1 10 2. This is 0. Row 2, this is 10 minus 1 is 9, 2 minus 10 is minus 8. Now, the next funda is to make this 9 a 0. How you can do this? Okay, multiply row 1 with 9 and subtract row 3. Okay, again, there will be an issue. If you do this thing, you will be in a trouble. Why? Because ये already 0 हो चुका है. Now if you subtract from this, so this 0, it will be reconverted into some numerical. I don't want this, so this operation is failed. What you can do? Okay, now go ahead with this thing. I can make this thing 0. How? Just do one thing. Multiply 2 with row 2 and row 1 minus row 2. So this is already 2. This will also multiplied by 2. This will become 0. So this is how you can approach. So you can apply row transformations. Either you can perform addition, either you can perform subtraction, either you can have a multiplication. But anyhow, try to convert them into this particular format. This is echelon format. Later on, if you again perform the transformations, if there is a possibility of reduction, you can reduce it into row echelon format. Also, that means reduced echelon format. Only the thing is, you're trying to identify the knowns. Okay, this x, y, and z. X, y, and z. But here we are having only three unknowns. But if your data set is huge data set, you are having many features. So just solving just analytically is very much different of substitution. You know what you kind of stuff you do in the substitution. If you are having x plus y equal to 1 and 2x plus 3y equal to 10, you just do x equal to 1 minus y, and you substitute here. But with few number of variables it is fine, but when the number of variables increase, this is not fine. Anyhow you have to apply matrix, then only you can solve. Okay, and here is the approach of solving, that is Euclidean format, and that's what my concept says. Okay, fine. Tomorrow I will wind up this linear algebra. I will proceed to the statistics. Okay, that's what I want to say in today's class.